we will be looking at the problem statement for checking if two strings that are provided as input being S and T are isomorphic string or not. What do you mean by isomorphic strings? We can say that two strings are isomorphic if the string S can be replaced into string T. What does that mean? We will be transforming the input string S to T. What does this transformation mean? Let's say in this case the first character is E. We will transform E into the first character in my T string. So I will transform E to A. I will then go to G. I will transform this G to D. So I will say G to D. Now if I transform all the characters in my string S, I will basically now get A, D, D, which is the string T. So if the string S can be transformed into string T, then we call these two strings as isomorphic strings. Now, in what case is it going to be said that they are not isomorphic strings? Because here we are just saying transform the characters in string S to the characters in string T. So if we just keep on transforming, then of course always these two strings will be isomorphic. To make sure this doesn't happen, there is a rule that we have to follow which says that you can transform only into one character from the transformed string T. What we mean by that is, let's see another example. We have F here. So I will transform F into the first character in my T string. So I will transform F to B. Then I have O. I will transform O to my character A here. So this will become B and A, which is B, B here, A here, A here. Then I have another O here. Now for these two strings to be isomorphic, I have to say that my O will now be transformed into a R. Now here comes the problem. The rule says that one character cannot be transformed into multiple characters in my string T, and because of that these two strings are not isomorphic. And with this logic in mind, let's try to reach a solution. The aim here is that when these two strings are isomorphic in nature, we notice that at this position whatever character we had, that character was replaced by the character at the same position in my transform string. So S string is my first string with E being at 0th position and with A being at 0th position. Then we went to G here. So G was at position 1 and D was also at position 1. And then we just said that we have G repeating. So whatever the transform value of G is, just pick it up when you try to find a comparison with the transform string. So that was also just 1. And here also the equivalent of G was D, which was also 1. So now if you see here, this transformation pattern that we just now created, so 0, 1, 1 and 0, 1, 1, was that both of these strings were transformed and then they were having equal values. And this is the core transformation logic which we are going to be using. There are multiple ways to reach this check whether these two strings are isomorphic, but what we can try, one approach is that transform string S, transform string T, make this pattern. So the pattern was that we found the first character index in the string. So E occurrence first was 0, G occurrence first was 1. So we take the first occurrence and of that occurrence we take the index and then reach a transformed string. This transformed string then we compare with the transformed string in my second string, and if both of these are same, that would mean they are isomorphic strings. And now that we have covered the approach here which equals that 011 is equal to 011, we can say that both the strings are isomorphic. Now let's convert this into code. How that will look is, we have this is isomorphic function. We will transform the first string. So let's say transform string s. So to transform this string, we can just write a function that will take a input string, and we will be converting the string within this function. And then I will also transform the second string that I have received, and then I will compare these transformations, and if both the transformations are same, that means that they are isomorphic strings. So the approach here is that we want to somehow say that if they are isomorphic, they will transform in the same fashion when we apply a transformation logic. And when we try to transform, what we will say is keep a tracker map, because we said we will be keeping track of this first occurrence index like we did for E. We said it's 0, we said it's G, it was 1, and then for the second occurrence of G also we said 1. So we have to keep track of this first occurrence index, and to do that I will just say constant first occurrence index is going to be my map, and within this map the index will be tracked. Then I will say I will have a transformed string that will be the outcome of my function, and at the end of my function I am just going to return the transform string, and then both those transform string from both the inputs s and t are going to get compared. And I will just go through all the characters in the string that I have received. So I will go from 0 up till the length of my input that I have received, and I will just pick the first character. So I will say C is the first character, and I will keep updating the current character as I go through my loop. And for this character I will check whether I have already found a occurrence in my first occurrence index map or not. So I will say if in my first occurrence index map this value of C already exists, then I already have my first occurrence index, which I will create my transformation string with. And if I don't have it, then I have to keep track of it in a map so that it doesn't change, because even though here the index was 1, here the index was 2, we still kept it as 1 because we want to keep the first occurrence track, not every occurrence track. And if it doesn't have it, I will just say set the index against the character within my map. And then I will say I have to generate my transformed string, which will just look like plus equals whatever the first occurrence of that character is. I will just say dot get that occurrence, and I will put a space after the end to make separation, because then when the strings are not isomorphic, we don't want to get confused by the order that gets changed. And this transformed string is then going to be returned at the end. And that's pretty much in terms of implementation what we do here, and that reaches a solution. Now basically what we did here is we took the first string, transformed it, and then we want to the second string. So when we transform the first string, it will look like 0 1 1, because for the first index, which is going to be for E, it's going to be 0. That 0 will go in my map. So I will store something like against E the index is 0, and against G then the index is going to be 1. And then from this map that I have, I will generate my final string, and that final string will be compared with the final string for the second string also. And in terms of the time complexity that is going to be involved here, we are going to be calling for the first string this transform string function, and this is going to have a time complexity of big O of n, with n being the length of the string that we have received. And again for the second string also we will be calling the same function, so it's going to get called big O of n, plus big O of n times big O of n plus big O of n is going to give us big O of 2n. 2 being a constant, we can just ignore it and say the overall time complexity is going to be big O of n itself. So I will just say big O of n plus big O of n, which gives us big O of 2n. To big the constant, it becomes big O of n. Now, why n and why not nm? Because this is a different string and this t is a different string. The strings are going to be isomorphic if only they have the same length. That's why we are saying that the length being considered here is n itself and not n for s and m for t. It's just going to be same. And in terms of the space complexity, the space that is going to be really required here is going to be storing this transform string, which is going to be equivalent to the length of my string plus the number of spaces up to that length. And that just gives us big O of n as well once. And then again for the second string also it's going to do the same thing, which is also going to give us big O of n. And similarly, the overall space complexity is also going to be big O of n plus big O of n, which is then going to give me big O of 2n, which basically translates to big O of n. So here for this transform string functions, the space complexity is going to be big O of n. Why big O of n? Because when we store here, this goes up to the length of my n. Whatever length I have, I'm going in loop for that length itself, and I'm putting this into my transform string. Now you will say we are also using a map here. What about the space complexity of that map? In this we store this ASCII values, so the map is going to have constant space complexity in terms of the data that is getting stored, and in terms of retrieval and saving also, it's going to be big O of 1 in terms of time complexity because it has constant time complexity for retrieval and saving. And that's pretty much it. Thank you for watching.